programming, why it would be a good idea to start programming with MIT App Inventor, all these cool things. So I'm really excited for this. And to make things as interactive as possible, I think it would be awesome if you guys could all turn your cameras on, as I see a lot of people are actually doing. It's always great to see your faces. So hello, my name is Kevin. I'm an undergraduate at MIT, and I got my start programming doing stuff on App Inventor. So this thing is very dear to my heart. It's very special to me because it's where I got started, and I think it's an incredible platform to get your start, because after you learn after you master the basics with MIT App Inventor, you can very quickly move on to other more advanced things. So let's get straight into it. Before we get started, I wanted to see if I could poll the group. I'm curious how many people have seen programming in some sort of fashion before. Like, has anyone coded before? How many people have not coded before? If you can raise your hand or like send a reaction in chat. How many people have never coded before? Oh, okay, interesting, cool. And how many people have a little bit of experience and are looking to develop apps or things like that? Cool. Okay, I'm not seeing a lot of hands raised. Would you mind just typing in the chat maybe what your background is like? It'll help me calibrate. It'll help me calibrate for the group to see like how fast they should go and all those types of things. So yeah, feel free to throw it in the chat. Cool. I'm getting a few responses. Nice. All right. So it looks like we have a pretty wide range of experiences. Cool. Nice. All right. Awesome. Nice. So we have some people who have no experience. We have some people who have quite a bit of experience who know other languages. So I'll give a brief introduction to MIT App Inventor, why you might care about using this, even if you have a little bit of experience, and then we'll dive straight in and we'll show you how to set everything up and then do something really simple. Hopefully it'll be accessible to everyone. Just let me know if I'm going too fast or too slow. I'm always open to suggestions. All right, sound good? Cool. So today we're going to be talking about MIT App Inventor. MIT App Inventor is this thing that was created once upon a time at Google to teach programming to young students without having them memorize a bunch of syntax. So at some point, Google handed this project off to MIT, and now it's maintained by MIT. And it's just simply a really great platform. Basically, at its core it's a block coding environment, which means that you don't have to memorize the specific syntax, the specific words that you have to type into your computer for it to do things. You can simply drag and drop blocks. And the reason this is so nice is because it abstracts away a lot of the really annoying parts of learning to code at first, and it allows you to focus on the idea of thinking like a computer, of computational thinking. It'll help you realize that programming really isn't as complicated as you might think. It's really just a large collection of if statements and while statements. And you'll realize that very, very quickly, you'll start to be able to build very impactful things. So in fact, the history of the students in this class is people who have zero coding experience have gone on to win the MIT App Inventor Appathon, which is just basically like a hackathon where they give you some kind of theme and you build an application that solves a problem, an important problem. They judge you and you get prizes if your project is good and your presentation is good. People have gone from zero programming experience to winning this competition. It's an international competition with lots of submissions from around the world. People have gone from zero to winning this thing in very, very little time. And if you ever want to build applications with something like JavaScript or Java, you'd have to learn a heck of a lot more. It'd be a lot slower. And you would run into a lot of annoying stuff that isn't very conducive to your learning about how to program and how to think about code, but rather it's just a bunch of annoying stuff that forces you to like get a lot of settings and parameters correct for the program to actually compile. So MIT App Inventor eliminates all this annoying stuff that has nothing to do with actually thinking like a computer. And it gets you straight to the stage where you can build things with cloud technologies, with IoT, with machine learning, all of these things very, very quickly. It's very useful as a tool. So that's what MIT App Inventor is, and why it might be important. And I think, I mean, some of you have already coded, and so you'll probably understand this slide, but basically the point is that you will never be able to learn how to code if you don't actually code. It seems really obvious. It seems like a tautology to you at first. It seems like, yeah, like obviously when you code, you should actually code. Like you can't learn to code without actually coding. But when people learn to program, sometimes the biggest obstacle is having enough confidence to actually just go into the editor and start dragging blocks around, or to start typing into the computer, because it's a little bit intimidating. Sometimes you don't always know what you're doing all the time. But the key is just to do it a lot, to really immerse yourself in the experience of thinking about programming and thinking about how to code and thinking about things, fun, creative apps that you can make, games that you can make. Really immersing yourself and being very hands-on is probably one of the biggest keys to programming. Cool. Yeah, so these are a few details about the class. I'm not going to be the main instructor for most of it, but I think out of respect for the other students in the class and the instructor, please be present and on time. When you have a lab session in class, so basically how the class will work is you will be introduced to some theory, or basically there will be some slides about a topic in programming that the instructor will present. You should just listen, take notes maybe if you want to. And then after that, immediately following it, we'll have a lab. And the lab is where you will put those slides to work. So you'll actually be coding along with the instructor on a cool in-class demonstration. And so the key is, while the instructor is doing the coding, think about what you would do and actually do the coding along with the instructor. Because like this slide says, you have to actually code to code. You can't just look at code and be like, oh yeah, it seems reasonable. No, it's a lot harder to actually do it. So make sure you always do it. It's a lot of fun. You always learn unexpected things. Make sure to keep your hands dirty. That's the key. Whoops. Okay. There's going to be a video recorded if you ever want to review the PowerPoint. Please show up to office hours if you have questions, or if the homework is getting you stuck somewhere. That's what the TAs are for. Feel free to meet and chat amongst your friends in the Discord group. Please keep in mind that we want to foster a culture of collaboration. So if anyone has a question, there are no stupid questions. Please ask it in the Discord. And in the Discord, keep in mind that everyone has different experience levels. So even if a question seems really obvious to you, it might not be obvious to everyone else. So keep in mind to be respectful, be helpful, explain things in a very complete way. And keep in mind that, if you already know how to code, someone had to teach you, and that person taught you things that they thought were obvious. So make sure to pay it forward and be respectful and be kind, and make sure that things are constructive. Basically, just be friendly and everyone will be happy. Make sure to do your homework. Comes back to the idea that you need to code to actually learn how to code. And then there's this thing called the master document, which basically it contains everything I basically just told you. And it contains all the logistics, all the slides, all the lecture, PowerPoint slides, videos, solutions, homework assignments, all these kinds of things. It'll be one unified resource for you to look at all these things. Cool. And the last note, don't take this too seriously, but the class does move a little bit fast if you haven't coded before. That is not to say that you won't be able to keep up, because we've designed it so that you should be able to keep up. But if there's anything that's ever confusing you, make sure to ask questions, because that's the best way to learn. That's what we're here for. And eventually, this should be exciting instead of daunting. It should be very exciting, because what it means is that USICO problems are not actually that hard at the lower levels. You will very quickly be able to do USICO problems before leaving this class. You don't need to learn a really new complicated language like Java or C++ or any of these things. And as we explore MIT App Inventor, you'll also get tidbits of other cool knowledge. Like you'll be able to see how databases work, how sensors work, how IoT works, how machine learning works. I think that'll be like a different class, but you'll be able to see in the MIT App Inventor environment, you can see all those things there. And you know, in your free time, you might be able to play with them. And, just make sure to keep up with the pace of the class. I see a few messages about the Discord. Kat, do you want to talk a little bit about how the Discord works and how people should manage their stuff?
Yeah, absolutely. So I think first of all, I just want to give some definition to who I am. My name is Kat. I am the senior administrator for this school, but also for this course specifically, I'm being a teaching assistant for 101. So that's for office hours. So before and after class, there will be like an open office hours where, if you have any questions or want to see a preview of like, how to navigate these homework steps, like I'm the person to go to. And we also have 2 more TAs joining us as well, and you'll find them then. But just to jump into the Discord, I see that Dr. Meng put in the Discord link. It is a temporary link, so make sure you do click on that and you can join the server. Basically, we use this Discord as our main mode of communication. So like Kevin mentioned, if you have any questions, like whether it's like seemingly obvious or more intricate, please just post it because it's very likely someone else bumped into the same issue. So there's like a area to chat about it or ask questions, but if you want to direct message like the teacher or me, a teaching assistant about something, feel free to do that as well. Like it's all about communication. There's also a channel that you're going to get after you change your Discord nickname to your first and last one. Then I will assign you the student role, which will give you access to the, the master document, also important links that can help bring you to MIT App Inventor website really quickly. So make sure to do that before the class ends today. And I think I pretty much covered everything. So I'll toss the baton over to Kevin again.
Yeah, thanks. Cool. So that's the Discord. Feel free to ask any questions about it in the chat. I'm sure Kat will be able to help you with it. So any questions so far? Nice, cool. All right, so just a few more notes. Yeah, just a few things that you'll be able to learn with MIT App Inventor that I forgot to mention before are that as I mentioned before, you can go from 0 to being able to win all these really cool things very quickly. One of those things, other than the MIT Appathon, is the Congressional App Challenge. I think some of you might have heard of it. It's basically this thing that's run by the government, where the government tries to encourage young kids to think about problems in their communities and to build apps, as the name suggests, to solve them. It's a pretty prestigious award. And as you can see, there's a screenshot here of a team that was once in your shoes. They once did not know how to code, but now they do. And they have won the Congressional App Challenge, it seems. So it's really, really exciting that you can go from no knowledge in programming to winning all these cool things, but most importantly, understanding how to code and understanding how to build applications that solve problems. And that's one of the beauties of MIT App Inventor. You try to do that with C++, you will run your head into a wall with issues about compiling and creating graphical user interfaces and all these other complicated things that don't matter so much when you're first learning about the whole ethos and the whole motivation behind app making. So that part is pretty cool. Nice. Oh, what is this? Oh yeah, this is an example of an application that people made. The motivation was basically that there are a lot of there's a lot of stuff that should be recycled. And yeah, I won't go through the entire video right now, but I can send a link to this in the chat and you can check the video out if you would like. It's very cool. All right. So as we kind of talked about before, this class will have a few instructors. I'm Kevin. There will also be an instructor. Her name is Annie. And then Dr. Meng will also partly be an instructor. Kat will be the TA, and then Kat will also be the administrator. So feel free to reach out to any of us. We're all in Discord if you ever have any questions about what's going on. All right. So What is programming? Does anyone who knows how to code want to offer a definition? I guess we kind of just gave you the answer on the slide. But yeah, okay, I'll just explain it. It doesn't really matter how you define it. There are a lot of different ways you can define programming. This is sort of like a mechanistic definition of programming. Like, what is it? Programming is basically the act of telling a computer what to do. There's this old joke that people would want computers to just infer what they want it to do just by telling it, hey, computer, write me a program that will end up in me consuming a piece of bread, like make me a piece of bread or something. But the thing is, the computer has to follow exactly every single instruction that you give it. You have to be very precise with the instructions that you give it, because if there's any ambiguity, the computer doesn't know what to do and it's not able to resolve that. So when you design programs, and programs are simply just sequences of instructions that you tell a computer to execute, you need a few things. You need it to be readable, because programming is at heart a human pursuit. You are a human, you're the programmer, other humans will collaborate with you to write programs. And if you cannot communicate, or in other words, if your programs are unintelligible, then you cannot work together. And teamwork is one of the most important aspects to programming. You have to write programs that are user-friendly. If you've ever used smartphone applications that are really buggy or really annoying or really slow, you'll know that they're very frustrating and they make your life really terrible. You also want them to be robust. Your programs should not fail in edge cases. They should not, if I take like if I go to Facebook or if I go to Instagram and I start spamming buttons, the app shouldn't glitch out because I'm just doing all this random stuff. It's got to be robust to all of these weird things that people will do to it. They have to be reliable. They have to be efficient. If you've ever used like an annoying app like Snapchat, maybe, that uses way too much of your battery when you use it, you'll be annoyed because it consumes so much power. It's running all these algorithms that are really slow and memory intensive and time intensive that it just drains your battery completely. That's really annoying. So you want things to be efficient. So there are all these things that you have to worry about in programming. But in this class, we will only cover a few of these. In particular, we'll touch on every single one of these in an introductory level of depth. And then in the future classes, you'll be examining some of these in further detail. So in terms of readability, MIT App Inventor is great. It's just blocks. They're colorful. They're color coordinated. It's really obvious what's going on. User-friendly, MIT App Inventor makes it really, really easy to design graphical user interfaces. This is also abbreviated GUI or GUI. And GUIs are really nice because they allow, essentially, when you interact with a smartphone application, you're interacting with the GUI, the graphical user interface. If you didn't have a GUI, you would have to like type commands or something into the computer for it to do things. Like imagine going to Instagram and saying, and instead of being able to click a button that says post a story, you'd have to type a command. You have to go to the command line of the phone and type Instagram.post story and then add a link to the exact file path directory of your picture. That'd be really annoying. So user friendliness is very seamlessly taken care of in MIT App Inventor. Robustness and reliability and efficiency are sort of artifacts of the code that you write. So we'll be teaching you primarily about computational thinking, about thinking like a computer does within the constructs of the operations that it can do. And we'll teach you to think about and reason about robustness, reliability, and efficiency. In particular, because at the end of this class, you'll eventually get to doing use code problems. When you do use code problems, the problems are pretty tricky, and often they test your ability to write robust, reliable, and efficient code. If your code is inefficient, it'll fail the test cases. And if your code isn't robust or reliable, in other words, if it's not correct, it'll also fail the cases. So this class will provide a pretty broad overview of all of these essential tenets of programming, and hopefully that'll get you started really, really easily. And keep in mind, when you first learn Java or you first learn C++ or you first learn some other language, you're often not worried about all of these fundamental tenets of programming. You're just worried about memorizing syntax, which is why it's not such a good idea to do that. And I think MIT App Inventor is a lot better in that sense, where you can forget about all the syntax stuff. You can just worry about what's really important to programming as a pursuit instead of the specific details that will annoy a lot of people. Okay, so we are going to dive straight into it. We're going to look at what MIT App Inventor is, how it works, and all these types of things, and I'll explain all the interface components. So instead of showing you the slides, I'll actually just do it along with you. I'm gonna go to an incognito tab because it'll allow me to like do the actual full sequence of things. I will go to Google and I can type in MIT App Inventor. So if you just Google MIT App Inventor, you'll get to this page. You can just click MIT App Inventor, and hopefully you're following along on your computer. But you go to MIT App Inventor and you can click Create Apps. So when you click Create Apps, you'll be asked to sign in. I'll sign in with my email. You should use your own email. And after you sign in, you'll be able to see this page. And this page, you'll be put on your My Projects page. And you can go to the top left and start a new project. I'll call this MIT Fundamentals 101 Fundamentals. And it's going to pop up a user interface. Put a thumbs up in the chat once you've gotten to this stage so that I know that you have. I'll give people a few minutes to do it. And let me know if you have any questions if I went too fast. But just as a reminder, I mean, I can do it again. Like go to App Inventor, click Create Apps, start a new project, type some kind of project name, and then open the project. Cool. Does anyone need more time? If you need more time, if you just type something in the chat, then I will know, and then I will wait a few more minutes. Cool. Okay, nice. Looks like everyone's good. Nice. 1 second. Cool. Okay, so we're on MIT App Inventor. There are a few things that you should take notice of. So the first thing is that there are multiple panels. On the very left, there's this thing called the palette. In the middle, there's this thing called the viewer. And over here, you have components. Here you have media, and here you have properties. And so here's what each of these things corresponds to. So with the palette, you can have components. And you can search these components, like if you really want a button, you can filter by the button, by typing in button. But basically the idea is that when you have an app, there are a bunch of components to the app. And these components are just pieces, blocks of stuff that can perform a certain action. For example, if you have a button, if you want to add a button to your app, you would simply just take this button and drag it over. So what is this is an object. This object has a few designed behaviors. For example, if you click on the button, then it'll click. And as we'll see later, you can code it up so that the button will do something when you click it. And notice when I click the button, the components thing and the properties thing, they change. And the button is highlighted. And the button is an object, right? So there are a bunch of properties that you can associate with it. For example, I don't really want my thing to say text for button 1. That seems awfully dumb. So what if I said click me, right? If I said click me, then it'll change the property of this thing. We can also bold the font. We can italicize the font. We can make this font mega big. We can make it mega small, but I like it mega big. You can change the type, the font, basically. You can change it to a serif font. This one's pretty nice. This next one is width. You can make it fill the parent. And in that sense, it'll fill to the complete width of the available screen real estate. And there are a bunch of other things that you can play with, basically. And so in your components, you'll see that there's a hierarchy. Button 1 is under screen, which means it's inside of the screen. And so If you'll notice, then if I add a slider, the slider is on the same level of the button because it's in the screen, but it's not in the button. So it's just on the same level. And so similarly for this thing, we can make the width fill the parent. There's a maximum value. Let's say the maximum value is 100 and the minimum value is 0. And the thumb position is at like 50 or 70. You'll notice that this slider thing doesn't actually render properly when we're in this viewer. And the reason is the viewer doesn't actually run the code. It just kind of shows you a preview of what it would look like. And it's not actually running. Like when you click the button, nothing actually ever happens. Or when you take this slider, you can't actually drag it. So how do we actually execute the code? So to execute the code, you need what is called an AI companion, an app inventor companion. I would not recommend the emulator. It is super buggy. And I would not recommend the USB because Wi-Fi is just a little bit more intuitive to work with. And so I'm kind of going out of order here. I want to show you how you can visualize or how you can actually put the components that you see onto a phone, because only then can we explore the other parts of the palette. Because there are certain objects with weird properties, like some of them are invisible, some of them are visible, and we'll talk a little bit about this later once we can actually mess with the code that or the app that we've created. So if you click connect, you'll see that if you click connect and then AI companion, you'll see that there's this barcode that shows up. And you'll notice that you have to have this thing that's called a companion app. So what you should do is you should go to your smartphone and you'll want to download this thing. It's called the MIT App Inventor Companion. So if you're on the Google Play Store, you would go here. And if you're on the Apple App Store, then you would go to the App Store. So the AI2 Companion, I'll send these links in the chat in case people would like them. Here, you should download these apps on your phone, because then you can actually take the MIT App Inventor app or the code that you've written and put it on your phone and run it. So what I'll do is I will cast my phone to the screen and I'll share it so that you can actually see what I'm doing. Cool. So, great. AirDroid has a network issue. Huh. There's one thing that I will try. Let me quit out of AirDroid and update it. But yeah, if you need more time to do this, let me know. Or if you have any questions as to how to do the or how to install these apps, let me know. But for now, bear with me as I try to get my phone projected on the display as I try to update AirDroid. So while AirDroid is updating, I can actually cast my screen in a different way. You should be able to see my screen now. And there's this thing called App Inventor. If you open it, you can hit continue, blah, blah, blah. And then there's this interface where you're supposed to be able to connect with the QR code. And then so that's what we will be doing in a moment. But does everyone have this app? If you do, if you don't, just install it. I think everyone should probably have it at this point. All right. Fingers crossed. This software is always really finicky. Cool. One more moment. In the meantime, does anyone have any questions about the class, about life, about what we'll learn, about what we won't learn? Any concerns? Let me know now. Are you serious? I have to purchase to do USB. Okay, this is a total scam. Okay, that's really sad. All right. Okay, well, basically what you should do is you should go to the AI companion and then scan the code. You can hit scan QR code and you should be able to scan it. And so if I share my screen again, using the other method, oh, nice. Sorry, bear with me for the technical difficulties. Tech is hard. Okay, but basically now you should see that it actually works. There's a button, and when I click it, it actually clicks, and then there's a slider that I can slide around. Hopefully that shows enough. So has everyone gotten to the point where they can connect and they can show things on their display? Okay, cool. So out of these things, there are a lot of visible components. There are like switches, there are text boxes, there are time pickers. And so like, for example, these things. And then if I go back to the companion, you'll be able to see that they just show up automatically without any further refreshing. So I can click to switch. There's a time picker, which allows me to pick certain times. So I click the time, I can toggle things around and it'll pick the time. So there are all these different things that you can add. These are the visible components, but there are also a bunch of invisible components, especially in the connectivity section. There's this thing called web, and you'll see that when I drag the web to the display, it actually doesn't show up as a visible component. It's got a non-visible component. And the reason this is the case is that the web component is a backend thing. So when you create apps, there's this thing called the front end, which is what the user sees. It's the GUI, the graphical user interface. And there's a backend, things that you don't see. For example, if I wanted to create an app to get the weather from a website, like to query the weather channel for my weather, you would use the web component. And the web component would basically send a request to the weather channel and be like, what's the weather in my current location? The weather channel would send it back to you, and then you would display it on your front end. So in this process, the procedure of taking this question and asking it to the weather channel and then getting back the results is totally invisible to you. That's why it's called a non-visible component. And as the class progresses, you'll get to learn about all these different components, about how to work with them, about tiny databases, cloud databases, all of these social related things, all of these sensors, even charts that you can make, maps. This one is really cool because you can navigate someone to a certain location using their phone. All these cool different things. Some of them are invisible, some of them are visible. The point is that you can organize them on your screen in this fashion. There's also this other trick that I want to show you guys, which is you can have these things called horizontal arrangements. For horizontal arrangements, you'll want them to fill the parent, and then you can drag things into them and you can put them together. Like for example, if I wanted this button and this list clicker side by side, because you'll notice that if I drag them just into the display, they'll be ordered from top to bottom. If I want them side by side, I can get a horizontal arrangement and then put them together. And as you'll see in the component tree, horizontal arrangement includes both the button and the slider, and it goes from left to right. And so you'll notice now that the vertical alignment is a little bit jank. So what we might want to do is go to the property of the horizontal arrangement and say align vertical center, and that centers this slider. Well, what happens if we want a label to display the value of this slider? What would we do? Does anyone have a suggestion looking at this layout box? If we wanted to have a label for this slider just right on top of it? It's not really a trick question. Yeah, okay, I see the answer in DMs. So basically you would have a vertical arrangement next to a horizontal arrangement or inside of the horizontal arrangement, and then you would put a label on top. And this label would basically contain the we would and you it doesn't work right now because we haven't linked the backends, but basically this would display the value of the slider. And if you want to see what this looks like on my phone, if you have an Android, it might look slightly different because I'm on an iPhone. But basically, we've created this layout where you have a button here, you have the text for containing the value of the slider. And of course, we haven't updated the code to actually do anything. So when we slide, it doesn't actually change. But we also have these other things. We have a time picker, we have a switch, we have all these cool things. But yeah, that is currently where we're at. Everyone good? Cool. So as you'll see, every single object has different properties. If you want to customize the way that your app looks or behaves, you can go into this properties thing and change anything you want. All right, nice. So you might be wondering, we have all these components. They're really dumb components because they don't work. What do we do? Well, notice that in the top right, we can see a designer tab and we can see a blocks tab. As you might imagine, the designer tab is to design the user interface that people will see. And then the blocks tab will be for the backend, for the logic that actually governs what happens when you do stuff, right? So, we have this dummy set up already. Why don't we try to make this thing work? Let's make this label work so that when you slide the slider, it actually does stuff. So the key here is the code in the program will tell every single component what to do. So for example, intuitively, you might say, when the slider has changed values, please change this label to match the slider's value. That would sort of be like you telling in natural language what you want the program to do. So how do we actually do that? We can write some code to do it. So before we actually write the code, I think there are a few things I should point out that are good coding convention. First, you'll always want to keep the components' names orderly. If you've ever coded before, these are basically variable names. And if you don't keep your variable names straight, you will get really, really confused when your apps become really complicated. Right now, we only have 7 components, but eventually we might build a really complicated user interface that has like 50 components. And if you can't keep track of what component does what, then you'll be really confused. So here's a format in which I like to do my component names. Basically, you can hit rename on any of these components. I like to have this format where I type what the type of component is, and then you type an underscore. So like type of component, you type an underscore, and then you have some kind of other name at the very end. So for a text box, it'd be a text box, txt-box. That's the abbreviation I like to use. And then you put an underscore, and then you should indicate what the text box is actually for. So a text box is something that people can type text into, and then you can read what they typed. We can, maybe this is the age input or something. And so when you just look at this, you'll know immediately that this text box is exactly for people to enter their age. And why this is important is because when you start coding, you have to point out which text box you're actually reading and writing from. And if you don't have your names straight, if you just have like some random arbitrary name like text box 1, you'll get really confused if you have multiple text boxes. So it's always good to keep your name straight. Like for buttons, I like to type btn underscore. This would be the button that says click me. I don't actually know what it should do, but maybe calculate. btn calculate. Imagine that we're creating an app that will calculate your BMI or something. In fact, maybe that's what we'll do. So I'm going to delete this switch because it doesn't actually do anything. I'm going to delete this time picker because we don't actually care. For this text box, currently, it's kind of just empty, like there's nothing in it. And so, when you use an application and you have text boxes, they often have hints. These are the kind of grayed out text that are inside your text boxes that give you a hint for what you should do. So in the hint, we could say type your age here. And then here you can see you can restrict this text box to be numbers only, which is really neat. So if I refresh the companion screen. And I go to the width and make it fill the parent. And we can start text. Oh, okay. Well, okay. Well, it looks kind of weird on my phone because I have an iPhone and App Inventor is mostly created for Android. But you'll see that, oh, whoops. You'll see that there's this invisible text box here at the very, very top that I can type into. It doesn't, you can't quite see it. And like, you can probably, there's probably a way to format it so that it actually shows up. But if you have an Android, you should actually see a text box there. Here, it's not super obvious that there's a text box. But you know, a way that we could solve this is, and this is sort of getting into the weeds of thing-ish, but you could have a horizontal arrangement. You can put your text box in it, and then you can add a label at the very left. And you can be like, oh, type your age here. And then you can put a colon. And remember, we really like our things to be aligned vertically centered. We want our horizontal arrangement. So we click the horizontal arrangement. We can make the width fill the parent. And we'll have this one also fill the parent. And then now it's a little bit more obvious what's going on. So if we go back to the app that we have, you can see it says type your age here. And if I click in this area, oh yeah, if you click in this area, then you should be able to see that I can type my age here. And there's this click me button that doesn't actually do anything. And there's a slider that doesn't actually do anything. So we have this interface, you can do a bunch of things with it, but when you actually interact with it, nothing happens. And the idea here is basically you want to write some code that can tell the program what to do when you interact with the display. So for click me, I'm going to change it. I'm just going to say calculate BMI. Let's just work with that. Calculate BMI. And this is ridiculously large. Let me make it small again. I don't quite like that the width is so big. So I can actually change the width to be a percentage of the parent. Let's say it's 25%. Oh, that's kind of ugly. Well, this is now shifted to the left. What we actually want is for this horizontal or this vertical arrangement to fill the parent. So now it's filling the parent, and this might be a little bit better. So let's make this maybe 40% so that it's not double lined. And so now we have this new interface that maybe looks a little bit better. Where you can type your age here, which is like whatever. And there's this button that doesn't do anything, and then you have the slider. So something that I actually got wrong is that you don't actually want to type your age, you want to type your weight. And then I guess we'll have a slider for height. These are just two different ways of entering both numerical pieces of information. So you can type your weight here. This, we should change the hint to type your weight here. And then this text we haven't linked yet. But basically we have this interface. Is everyone following so far? Basically, I'm trying to walk you through like an intuitive example of what you might want an application to do, and to reason through the things that we know, which is we can drag things into the screen that do things. But then the missing piece is we haven't written any code. So when we interact with the things that we have put onto the screen, nothing actually happens. And then we'll show how to bridge that gap in a second. Make sense? Nice, cool. Any questions so far? All right, neat. Okay. So the way you should think of coding is it's literally just some instructions that tell the components that you dragged into the display what to do when they're clicked or when they're interacted with or things like that. So we have this interface. Maybe the first thing that we should do is change it or like add some code so that this label actually reflects the slider's value. So maybe we should go to the blocks. So now in the blocks, you see a few components. You have the viewer, which is all the code that you've already written. Unfortunately, we've written no code yet, so there's nothing here. And then there's a bunch of stuff on the left, these blocks. So as you can see, there are some built-in blocks that are very general. For example, if you want to add numbers, you should go to the math block, for example. If you want to use trig functions, you should probably go to the math section. Basically, there are just a bunch of things related to real numbers. I don't know if they support imaginary numbers, but basically, if anything deals with numbers, maybe look to the math section. There's a logic section where you can chain together if statements. Don't worry about what that means if you haven't encountered if statements before, but like truth values like true or false, you can find them there. There's also a bunch of stuff you can deal with text. You know, when you text people, you represent the text that you type in to the phone as a string, and you can do a bunch of stuff with strings. And we'll talk about this in future classes, but like you can split a string, you can trim a string, you can turn everything into uppercase, you can turn everything into lowercase, you can get the length of a string, you can add strings together, a bunch of different things you can do with strings. Lists, if you ever have a lot of different things and you want to put them all into one unified data structure, you can add things to a list, like a list of restaurants or a list of people. You can have lists. You can actually have dictionaries. So a dictionary associates a key with the value. If the key is somebody's name and the value is their, for example, grade point average, then you can have a dictionary where if you ask the dictionary, hey, what's the grade point value of Alice? It'll give you a value, 3.5. What's the GPA of Bob? It'll give you a value, 3.6 or 3.4 or whatever. Those are dictionaries, very useful. Colors, this one's neat. I don't actually use this a lot, but I guess if you want to change the color of a certain component, you know, you can change the color using these things. Variables, we won't talk too much about variables today, but basically variables help you store information that will later be important for your application. For example, you might see some use cases of variables already on the screen, like type your weight here. Well, maybe we should store their weight in a variable because variables are just things that we need to remember to compute the final answer. And for reference, like BMI is called body mass index. It's like some combination of your weight and your height. And so it's a pretty simple formula, I think. So we can just teach our computer to calculate it and it'll be pretty cool. So we have blocks, more blocks, procedures. We'll not talk about this today too much either, but this ties into the reliability, the readability part of programming, which is that you want, if you have like a sequence of steps that you use very frequently, like for example, in programming, a very common sequence of steps that you want to do is to take a list of numbers that are unsorted and sort all of them from least to greatest. It's actually not super obvious how to do this. It's actually kind of complicated. But if it's a procedure that you use commonly, you'll want to just put it in this procedure block, and then you can just call it whenever you want. So imagine somebody comes along and they're like, I have this way of sorting numbers. Don't worry about how it works, but I guarantee you, if you call this function on this list of numbers, when they're totally unsorted, it'll return to you a completely sorted list. Somebody's just like, trust me, bro, like it works. If that's the case, then you can simply just go to the procedure and call it, and it'll just work. That's what we call abstraction when we program, and it helps us organize our code so that we don't have to rewrite sequences of steps that we use really frequently, and we don't even have to understand how they work as long as somebody tells us that it works. Hopefully you can verify it for yourself that it actually works and you don't just trust them. But if you do trust that it actually works, you can just call it and you don't even need to know how it works. That's called abstraction. Minimizes duplicated code, makes things more readable, and is sometimes really nice because if algorithms get really complicated and you don't know how they work specifically, but you know how to use them, then you're in luck. So that's kind of an overview of all the built-in blocks. And then you'll notice that there are a few commands that are kind of that are special to all these different components that you've dragged in to the display. So here's where the naming becomes really important, because if all of these things were just generic names like text box 1 or button 1 or label 1 or slider 1, when things get complicated, you'll be like, what the heck is everything? Like you can't see the designer, you can't see all these things that are going on. And so if you're just in the block section and you want to, for example, read the input of the text box, you'll get really confused if you have multiple text boxes and you don't know which one corresponds to which. So that's why naming is always very important to keep track of. And so for every single component, you'll have different types of code that you can write. For example, with web, you can perform what is called a post request or a get request. Basically, that's saying I'm going to post a question to the server. Like I'm going to post a question to the weather server, and then after I post it, the weather server is going to be like, oh, you're asking for the weather in Cambridge, Massachusetts. Let me send it back to you. And then there's this function that you can use to determine whenever the server has sent the information back to you, and then you can do something with it. And so that's a really powerful way of interacting with data in the world, which is just to ask a server a question and it'll send it back to you, and then you can use it in your app, which is really neat. So yeah, everyone's got their own specialized components, and we'll see how we can string these together to make something work. So let's go back to our designer and recall what types of things we need to create. So the first thing we were going to focus on, right, was the slider. We want, whenever the slider changes, to update the text in this label. So how might we do that? Well, the first thing to look at is literally just to go to the label in blocks. This is, oh, see, we didn't name our variables, and now we're confused as to which label is which. So this label, I will abbreviate with LBL, and what is it used for? It's the label for the height slider. And this is slider, let's rename it just slider height. So this is our slider for the height, and then this is the label for the height slider blocks. Now we can go to the label height slider. Let's look at all these components. This is a complete set of everything you could possibly want to do with this label. You can like change its background color. You can set a bunch of properties of it, like you can make the height really large at any arbitrary time if you ever wanted to. You could do all these things, but what we're actually interested in is we want to set the text of the height slider to something, right? So let's drag that block out. When you drag the block out, it's kind of like a live block. It's going to do stuff. But you'll notice that there's an error. Why is there an error? Well, you'll notice that these blocks in MIT App Inventor are designed in a very specific way. This block has an indent on the left, which means that it should fit into another block, but there's no block that surrounds it. So it doesn't know what to do. And if you think about it, it actually kind of makes sense, because when I have this app and it's just sitting there, how am I supposed to know when the height slider is supposed to change? Like, it's just sitting here. I'm just doing a bunch of stuff. And I have this piece of code that's just sitting in the vacuum that's like set the text to whatever. How do you actually know when to call this? And so that's where the idea of callbacks becomes important. So a callback is basically a function that is called. A function is just, again, a series of steps of a program. Basically, a callback says whenever an event occurs. In this case, the event would be if somebody touches the slider. If there's an event, please run the following code. So let's see what that looks like. If you go to the slider, there's this callback. It says when slider height dot position changed, do something. This is what we call a function. It's basically saying whenever somebody touches that slider and moves it around, we want to do something. And what do we want to do? It's really nice that MIT App Inventor directly has this block fit into that block. And so now it snaps in and we don't have any floating code anymore. There's a very specific time at which this code is activated. So what do we want to change it to? Well, a function can have parameters, because when the position has changed, you need to be told what it was changed to, so you can do something about it. So we can actually go to the thumb position. If you hover over it, you can see that you can get the thumb position or you can set the thumb position. So what if we get the thumb position? Let's say that we just set the text of this slider to the thumb position. And as you can see, MIT App Inventor is really nice because you can't accidentally set the thumb position while setting the text. Like, that just doesn't fit. It does not compute. What you actually want to do is get the thumb position and then set the text to that thing. So now we have this code. In the bottom left, it shows that we have no warnings. Great, let's test it out. So let's go back to our thing, our app, and let's slide it around. So now you can see there's this really nice sliding action where when I slide, it changes it between 100 and 0. Super neat. There are a few problems. One of the things is like, I'm pretty annoyed that I see a bunch of decimal places when I slide. Let's say that we always want to round to the nearest inch or the nearest centimeter or whatever it is. How might we do that? Well, I mentioned earlier, if you're dealing with anything that has to do with numbers, you might want to go look at math. We're looking for something to round. And so lo and behold, there's this thing called round. You can put this into round, it'll round it. And then you can put that in here. So now what this code is saying is you should set the label text to something. What is that something? That something is the rounded number of the thumb position. So now what happens when you go to your app and you do the screen mirroring thing? One sec. Now when you go to your app and you scroll around, you can see that it has nice integer values between 0 and 100. Cool. Is everyone up to this point? Is anyone? Okay, so people are almost to this point. Some people are there and some people aren't. No worries. I'll give you a few moments to like get your stuff together. So in the meantime, while you're getting this together, let me just Google the BMI formula. So the formula for BMI is weight in kilograms divided by height in meters squared. That doesn't make any sense to me. Height is not measured in meters squared. Okay, so you square the height, and that's on the denominator, and then you have the weight in kilograms. So I want to ask you guys whether you want us to do the BMI thing in pounds and inches, or weight, or pounds and inches, or kilograms and meters. Does anyone have any opinions? They have formulas for both. It's just off by a conversion factor, but any thoughts? No opinions? Oh, I feel like that's a hot take, Austin. No one uses kilograms and meters in the US. Yeah, we'll go with that though. It'll test my ability to remember what I weigh in kilograms. I actually don't know. But okay, cool. Does anyone need more time on the slider thing? Cool. Nice. Well, remember, we were interested in code that is user friendly. So maybe one of the things we want to indicate is what units we want. So let's go to our text box and let's set the text to your weight here in kilograms. And then here for the label, we actually might want to add another label that will indicate that you should have a height, or your height should be indicated in meters. So what I actually kind of want to do is to move this horizontal arrangement or this vertical arrangement out. It's kind of weird looking with the buttons. I kind of did that earlier just to make everything more obvious, to demonstrate the existence of vertical and horizontal arrangements. But now that we don't need to do that, let's not do that. Let's add a horizontal arrangement here so that we can put a text next to the text. And so let's put a label here. This label will simply say your weight or your height in meters, your height here in meters. And then this text will be the text of the slider. And let's just change the text to slider text. So now, if I go to my screen mirroring thing, you should be able to enter your weight. Let's say that I'm 70 kilograms. And now there's also this new thing here that says your height here in meters. There's a little bit of a problem because when you first initialize the application, it just says slider text instead of actually showing the current value of the slider. And so I'll show you guys how to fix that in a moment. But now you can see that we have this nice slider that has this cool behavior. And it's all accomplished because we wrote the code to do it. But guess what we did not write code for? Calculate BMI. When you tap this button, there's no code that tells the program what to do when you ask it to calculate the BMI. So that's now what we need to do. All right. Cool. So let's go ahead and do that. Let's go back to our blocks. And before I do that, I'm going to take our button and just make it fill the parent. That looks a little bit nicer. Nice. Okay. So let's go to the blocks. There are a few things that we want to fix. The first thing is that we don't want it to just always slice slider text. We want it to automatically populate the value of the slider. Does anyone actually, before I dive into it, does anyone have any ideas for how we should fix this? How do we get this value to match the value of the slider when we first initialize the application? Because remember, what our code says is when the slider position is changed, we want to set the text to the rounded thumb position. But what happens if nobody changed it? It's this value is just going to stay at whatever we tell it to be. So how should we fix this problem? Any ideas? Okay, so Patrick has this idea, set a default. Excellent idea. So one intuitive way to do this would just be to say, well, you have this slider, right? And this slider has properties. And there's a minimum value and there's a maximum value. And you'll notice that initially the thumb position has a 70 in it. So what can we do? We can simply just take this text and type 70. There's a little bit of a problem with this, right? Because what happens if I initialize the thumb position to 100 and then I go to my screen share and I look at our application? This is bad, right? Because our slider says it's at 100%, but we forgot to change this default value in the text, and now it's messed up. Now it just says 70. So if I were to code the application like this, it would not be very readable. It would not be very maintainable because a programmer that comes and looks at this code after me and just decides to change the default thumb position and does not know that this value is not linked explicitly to this thumb position will be really confused, and their code will be messed up if they just don't understand this fact. So what we can actually do is use another callback. So if you go to blocks, there's this really neat thing that's in the screen set of blocks. And there's this thing called screen initialize. Now, there are only two possible cases, right? The first time that we initialize the screen, the slider will have some value. And then after the screen is initialized, this code will be completely okay. Like it'll take care of all the possible cases. Once the screen has been initialized, maybe we should populate the slider height. And then once it's changed, we've already taken care of that. So what we can do is we can run the same code, but when we initialize the screen, we can duplicate this code and move it over here. And that will say when the screen is initialized, we should set the height slider text to the rounded thumb position. But guess what? There's an error. Does anyone want to point out why there's an error here and why this shouldn't work? Why doesn't this work? Why is there an error? Anyone have any ideas? Yeah, so exactly. There are no values. So here's where the idea of the scope of a variable becomes important. I won't talk too much about this because I think it also comes up later. But essentially, when this callback is called, there's this variable that's defined here. When you see a variable defined inside of a block, it's called a local variable, and it's only available within this function block. It's not available everywhere else. The intuitive reason for this is variables that are passed through a callback should not be available everywhere. That doesn't really make sense because this thumb position is specific to the case where the slider's position was changed. When you change it, it's changed to a thumb position, but it's not like if you didn't change the slider, this variable would not be defined. And so if you were to call it from here, it wouldn't make any sense. So for that reason, this is designed to be a local variable that can be only accessed within this block. So we're kind of out of luck if we want to get that variable. Does anyone have any ideas for where we might find this property elsewhere? Or where should I look to get the value of this slider when the screen is initialized, when nothing has already been changed? Any ideas? Yes. So it'd be quite a good idea to go look in the blocks for this slider. So we'll go to the slider, and we can see that if you just scroll down, there's this property that you can obviously set the thumb position if you want, but you can also get the thumb position. And so this thing can plug straight into our code. And so now, whenever the screen is initialized, it'll set the text of this slider text to the thumb position, and it'll gather it dynamically. So no matter what you go ahead and change, no matter what you change the thumb position to, I could change it to 0. And even though whatever like random value I put here initially, whenever my screen is initialized, it'll actually run the code that I wrote, and it'll change it to the correct thing. So now it's at 0, right? And I change it, obviously it works. But it started at 0, and the display said 0, even when it originally said 70 here. Or if I just said, like if I just had some random text here, even if I have some random text there, this piece of code will take care of the case where the screen is initialized and you have the wrong piece of text, and it'll set the position of the slider to the appropriate value. You can see it set to 0. Cool. Yeah. And so the nice thing about MIT App Inventor is that basically documentation is inbuilt to this IDE or this development environment. If you're ever confused about how to do something, you should just go around and scroll around the blocks. And if you scroll around the blocks, it'll probably come up. And that's one of the great things about MIT App Inventor, because when you're coding with a regular language, there's so many different things you could possibly do. Like the syntax for those languages is really complicated, and it's often impossible for you to just scroll through a list of commands and figure out what you need to do. And so oftentimes then you need to Google, and that's a little bit harder. But here, if there's anything related to, if it pertains to a slider, just go straight to the slider block section and scroll through and see if anything kind of makes sense. And so here I was just able to slide the thumb position over here. Cool. So we took care of that bug. There's another thing that we need to take care of, which is what actually happens when you click this button, right? And so there's another callback for that. Callbacks, just remember, if you're ever dealing with events, like somebody clicked the button or somebody toggled a switch or somebody messed with a slider thingy, it doesn't matter what it is. As long as somebody has done something, it'll activate a callback. And if you want to access callbacks, you should just go to that component. So we can go to button calculate, and then the callbacks or the functions are always set in this yellow color, which is really nice. Again, another benefit of App Inventor. But you can see this thing that says click. So whenever the button is clicked, this function will be run. So what do we actually want to do? We want to set, or we want to output a BMI, right? Well, we actually don't have anywhere to put the BMI, so we should actually put a label here. This label, we'll rename it. Let's call it label BMI output. It'll be where we put the BMI. For now, we'll just set it to some BMI, and then we'll say it's like calculated. So we have this label here. It's called label BMI output. We'll just put it here. You can go back to blocks. And basically, we'll want to set the text of this BMI output thing to the output of a calculation that we do. So we should probably go to math, because we're going to be doing a little bit of math. And let's recall what the CDC says the BMI equation is. So for kilograms and meters, the formula is weight divided by height squared. So let's kind of build our abstract syntax tree. We have a division here. So let's drag out a division. Then we also have a squared, because we need to square the height. And if you ever want to just type a number, you can drag this number thing and you can do that. So now you have something divided by something to the squared power. And then now we need to fill in these two blanks. What is this blank and what is that blank? This blank is the weight. right? Oh, is it the weight? Yes, it's the weight. So if you want the weight, remember, okay, well, first of all, I misnamed this. It should actually be text box weight input. So that's why you need to keep your name straight. So this is your text box of the weight input. And when you input your weight, you can actually go to this text box and get its property. It's text. This will be a number. And then you can go to the slider and get the thumb position. The thumb position is going to be also a number. And so now what you're basically telling the code to do is whenever the button has been clicked, you're going to run this program. This program says you should set the output of the text to this arithmetic expression that we constructed from the CDC's website. And so if you were to do this by hand, you'd probably take a long time because squaring things is hard, dividing things is hard, especially with decimals, blah, 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 blah. And we should check out our app. And there's going to be one last thing that will not work properly that we will fix. So we have this thing. Let's say, I have some weight, I have some height. So let's say that my weight is like 60 kilograms. And now we have our height. Does anyone see any problems with this application as we have it? Anyone notice anything a little weird? Clues, it has something to do with the slider. This slider is a little bit strange. What's wrong with this slider? Okay, well, it is ugly. But yes, Kevin's got the right idea. Height in meters should probably not go from 0 to 100. If you're 2 meters tall, you're already in like the top 0.001% of the population or something. Like very few people are more than 2 meters tall. So actually, is anyone? Yeah, well, anyways. So that's something we need to fix. So we can do a few things. We can either convert to centimeters, or we can simply change the scale of this slider. I think what I will do is to actually just change the scale of the slider because, well, it's a little bit more intuitive. So we can go to this thing and we can change the max value to 3. I think like there's, okay, tallest person in the world. Tallest person in the world. How tall is he? Tallest person in the world. Okay, how tall was the tallest person in the world? This is profoundly unhelpful. Okay, never mind. Okay, Google, the Guinness World Record book says he was 2.72 meters tall. Great. So we can set an upper bound for height. I don't think anyone has ever been 3 meters tall. So our maximum value will be 3 meters and the minimum value will be 0. So let's go to our blocks. There will be another problem, yet again, another problem with this code. So obviously we can input our weight, blah, blah, blah. We're like 60 kilograms. But what's going on here? We're sliding and we can only select either 0, 1, 2, or 3. That's really dumb, right? Something is wrong. So the problem, remember, is that we did this rounding thing. We rounded. And so maybe what we should do is to not round. Maybe we should round to 1 decimal. What do you guys think we should do? What should we do? Let's round it by formatting it as a decimal number. And we want to round it to 2 places. Let's say we want it at 2 places. We can do the same thing here, but replacing that block here. So hopefully this will be good. So let's try our application again. Okay, so we have our weight, we have our height. Nice, we can choose stuff. Let's say I'll put my current height. I think my weight is a little bit higher. I don't actually know. But yeah, let's say I'm 176 centimeters. If I calculate my BMI would be 19. And that's actually a very low, I think that's a healthy BMI. question mark. But you know, if we wanted to make our app more useful to people, maybe we should just, for information, BMI scale. We should probably add the information to the to our app. So let's Google what a healthy range is. Okay, so basically normal weight is 18.5 to 24.5, overweight is 25 to 29, obesity is 30 or greater. Maybe we should just copy this over. So let's actually just copy this over. We'll go to MIT Inventor, we'll go to the designer, and we'll add a label that doesn't actually do anything, but we'll just have all this text here. And you'll see that it's not too happy. It's like got everything in a line. One thing that we might do is we might add returns. Okay, maybe you can't add returns. That's so sad. Oh, no. Okay. So actually what happens is that it'll display incorrectly on the viewer, but when you actually deploy it onto a computer or onto your phone, it'll show up correctly. Like it'll have all the returns in place. So yeah. So your BMI will be here, and then you have a bunch of stuff here. I don't actually like the order of this. Maybe we should move the BMI a little bit further down. And we can just add your BMI. So now, hopefully, if we put everything together, we'll get something that works. So final product, you know, you can have your weight here. I'll type 65 kilograms. My height, I can slide. If I'm like the tallest person in the world, I'm over here. If I'm the shortest person in the world, I'm over here. I am somewhere in the middle, and I can hit calculate BMI. And there's one last thing that is a problem. When I type everything in and I click the calculate BMI button, the your BMI colon thing actually disappears, and it just puts the BMI there. So the way we fix this is we can probably just use a horizontal layout, horizontal arrangement, and you have your BMI here, and then you know, we can just remove all the other stuff, the calculating thing, and then we can add another label. Oh, whoops. We can add another label that says label. Oh, well, we don't need to change the name because we don't interact with it, but basically we can say your BMI. So now, hopefully things should be working fine. So if I'm 70 kilograms and also 180 centimeters, calculate BMI, it says my BMI is 21.7. Cool. Nice. So there's one last thing that you guys might notice is wrong with this application. Does anyone want to point out what it is? It's a little bit of a subtle thing that is actually never going to be a problem if people use the app correctly, but if people use your app incorrectly, it will be a problem. It has to do with the equation. Anyone want to look at this equation and tell me what's wrong with it? Oh, yes. Patrick says negative numbers. There's another thing. There's positive numbers. There's negative numbers. What types of other numbers are there? Ah, yes. Okay, you got it. There's a problem when you divide by 0, because we divide by the height squared, and if your height is 0, I mean, in principle, like if you have some non-zero weight and you have 0 height, then you have like infinite density, and that doesn't make any sense. And so the app will kind of be sad. So if you set this to 0 and you calculate BMI, you'll get this error thing. It'll say trying to divide 70 by 0, the results might not be valid. And it says your BMI is positive infinity. Wonderful. So it turns out the other thing that someone mentioned isn't that much of a problem, because apparently we can't type negative numbers into this thing. So that's not a problem here. If it is a problem on Android, then maybe you can add a check to fix it. But there is this problem of this positive infinity thing. So There is, so I'll quickly show you how to fix this problem. And maybe we'll use another hidden component to actually fix it. So I can show you a useful tool for both debugging and also indicating errors. But there's this thing called the notifier. And if you drag it onto the display, you'll notice that it shows up as a non-visible component. So the notifier can basically indicate to the user anything. You can write a message to the user and it'll sort of pop up on their screen. So what we can do is we can use an if statement. I know I'm kind of like moving, I know I'm just introducing a lot of stuff that I probably wasn't supposed to introduce today, but I don't think it matters because you guys are really smart and you're catching or you're following really nicely. But basically, we can use the if statement to say, if somebody has entered and like an invalid value, then we can warn them. And you can warn them by sending a notifier thing. So in this button calculate.click thing, we should add the check. Because the check should be once somebody has asked us to calculate, if our slider has some kind of zero value, then we should indicate to the user that they're tripping, that they're not using the thing correctly, and that it's impossible to have a zero height. So we would add an if statement. So we go to the control because an if statement is a control thing. So we can add an if statement, and we can basically say, if the input height is equal to 0, then you have messed up. Oh, let's go to math and let's drag over 0. If the input height is 0, then you've messed up. So then what we should do is we go to the notifier and we can log, or we can show alert. And we can tell the user like, hey, what are you doing? So you can go to text and you can drag this empty string and you can type something in it that you can show the user. Hey, what are you doing? You can't have a height of 0. You can make this message more formal if you're actually making a real app. I'm just messing around. But so if this value is 0, then you should show an alert. You should be like, we can't calculate your BMI. You can't do that. But then there's an else condition. If this is true, it'll run this first block, but if it's not true, it'll run the second block. And you can then say, well, if you have a valid input, where you don't divide by 0, then you can just continue as normal with the computation. So now let's check this out. Let's see what it looks like when we actually use it. So now we have some non-zero weight, and if we click calculate BMI, it'll show an alert. It'll be like, hey, what are you doing? You can't have a height of 0. This will remind the user that you shouldn't have a height of 0. And then it'll remind them that like, hey, you can move your, you should move the slider to reflect your actual height. So yeah, here this dude has a 5,000 kilogram weight, but a 1.3 meter height. And so their BMI is through the roof. There's also another solution to this. And I wanted to show you the notifier because the notifier can be a really useful tool when debugging in the future. And it's just also another example of a component that is invisible, but still very useful. And also I wanted to show you guys if statements because they're really simple. The other solution to this is pretty obvious. Just make sure that no one can ever type a 0 value. So we can just type a 0.1 value here, minimum value, and no one will ever encounter this problem. So always many solutions to different problems. The issue with setting a minimum value is like sort of you never know who, you never really know what the minimum height for a human being is. And so you'll have to be careful not to set this minimum value too high. All right, so that is a very brief overview of all the things that you can do with MIT App Inventor. It's really quite simple, honestly. All the complexity comes with all of these future things where people have created all these really cool components for you to use, for you to build very compelling apps. It is totally realistic to me, that like if you haven't seen programming until today, that you could start building things that could actually be useful and fun, like fun games or useful applications that can help you do a certain task in your life that's really boring or repetitive. You can be building these apps in no time, in within weeks or maybe even days, if you just look at the stuff carefully and are really quick. And so that's what I find really exciting about this interface. It's super intuitive. As you can see, if you're ever confused, you just like scroll through the blocks to figure out what you can do and what you can't do. And once you start learning about for loops and while loops and then more conditional stuff, you'll be able to do a lot of complicated things very, very quickly. And so that's pretty much all I have for you guys today. Do you guys have any questions or any comments, any things you want to point out? So there's one last thing that I need to do, which is to show you guys how you can publish things to the gallery. And when you're publishing things to the gallery, this is sort of like, I think this is the way that you'll turn in your homework, actually. So, and basically it's a way of taking all the code that you've written and putting it publicly on the internet. So as this top bar seems to suggest, when you click publish to gallery, it'll be able to, you'll see this interface where you can give it a name, like this is MIT Fundamentals of Programming Lesson 1 walkthrough description. I'm kind of lazy, I'll just copy paste this. Credit Kevin Meng, just write your name here. More info, if you want to write anything, you can just write anything. I'll just copy paste this. You have to attach an image. So I don't know. I'll just attach this random image and then you can hit submit. And then you can then go to your apps and you can see Fundamentals of Programming Lesson 1 walkthrough. And then you can take this permanent link and you can copy it and you can send it to people. So I think this is how you're going to be submitting your homework. And so if I send this to you guys should be able to click on this link and it'll show up here. I don't know what this picture is, some random thing from a class. But yeah, that's pretty much it. It's honestly very simple. Like the workflow is pretty easy to get used to. And eventually when you start writing algorithms, you'll write interfaces for you to pass data in. You hit a calculate button and it'll give you the output, the results of running the algorithm. And then you can basically do Usico and MIT App Inventor. It's actually not as tedious as you might think it is. It's pretty nice. And it allows you to focus on, again, computational thinking. All right. So I am going to hand off everything to I think either Dr. Meng or Kat. I think they have a few comments on administrative things as like office hours or the master document or things like that. But yeah, I hope you found this easy to follow. If you already have a little bit of experience, I hope it wasn't too boring and that you're excited by the fact that you can build full-fledged apps that you can save into your computer and publish on the App Store like really, really easily. This is something that would take you multiple years to probably learn to do really well if you use something like React Native, like an actual JavaScript-based app development environment. So I hope that's exciting. I hope it's exciting that you can focus on the process of finding and solving problems with programming as opposed to just being bogged down in the details.
Thank you so much, Kevin. So I just want to make a quick comment about office hours. You probably got it from the onboarding email from registering for this class, but there are two office hours that kind of sandwich between a lecture. So the first office hour is basically like the general Q&A that goes from like 7 to 7:45 p.m. Eastern time. And I know everyone probably comes from different time zones, but just due to conversion, if you will. And then obviously we have the lecture for an hour and a half from 8 to 9:30 Eastern time. And then 15 minutes after the lecture ends is when the group discussion, which is the second office hours, begins. And office hours are both 45 minutes long. So if you have any questions or if you just like want to test out your app together live, this is the space to come to. But obviously for today, because this is the first lesson, we didn't have a first office hour, but for the subsequent ones, there will be one. And if you have any questions or don't know your student ID, let me know, and I'll get that message to you. But while we're still live, does anyone still have yet to join the Discord channel? And if you need a new link, please let me know. 1, 2, 4, 5, 6, 7, 8. Okay, let me send it over to you. So someone asked about the Discord link, so I'm just going to send it to everyone in case you haven't joined yet. And if you're not sure how to change your server nickname to first and last name, I did create actually, it might be easier to share my screen. There we go. So I did create this Please Read channel. So it gives you a little step-by-step tutorial on how to get your student role through changing your server nickname. So you can use that if you want. Class materials, master document has everything. This is your best friend. And yeah.
What we're gonna do? What we're gonna do in the office hour session for today?
So the second office hour is like group discussion. We can talk about things that you learned during the lecture that Kevin provided. And also the first assignment is up in the master document. It is the bouncy ball one. And if there's also the, let me just scroll down so you guys can see. So there's the lecture slides, and at the end of the slides, it'll give you a step-by-step tutorial on how to do the first homework actually. So it kind of get like the softball toss. But for this first assignment, we just encourage you to not only complete this homework, but just familiarize yourself with, oops, that is not what I was going to do. Familiarize yourself with like the palette, the gallery, how to publish things, just review everything. But the more you're able to experiment with MIT App Inventor, the better and quicker you're able to adjust.